Welcome to this video on section 1.2, displaying quantitative data with graphs. So one of the nice ways to just get a quick look at what a distribution looks like is a dot plot. And all a dot plot is you have your number line on your horizontal axis, make sure you label it, and then you put dots, thus the name dot plot, wherever you have a piece of data. And it gives you a nice overall look of what the data looks like. For example, in this scenario of goals scored, you can see it's clustered around 1 to 5, and there's a couple out there on the ends, the 9 and 10. A distribution, we're going to describe it in a few ways. One is symmetric, and usually we're going to say it's roughly symmetric. We like to hedge our bets a lot in statistics because nothing is absolute. So it looks the same from the center on both sides, look roughly the same. We can have a skewed right. Now, the skew is based on where the tail is. The skew here, because the tail, if we were to draw a little curve, seems to go off to the right. So that's skewed right. And when we talk about mean and median, if we have something that is skewed right, these high values are going to take the mean and skew it higher. So it's skewing the mean to the right. That's why the terminology is the way it is, because that extreme value will pull the mean towards it and therefore skew the mean to the right of where it really is, the center of the data really is. And as you can guess, skewed left is just the opposite. If you have extreme values on the low end, it's just where the tail goes off, it's going to be skewed left. And as I just said, it's towards the longest tail. That's the first thing people just mess up, but after a little bit, you'll get a hang of it. All right, so describing distributions, I like to use a little mnemonic called SOCKS. And so that's whenever we're describing a distribution, we want to talk about shape. Outliers, we also want to add in here gaps. They kind of go with the outliers, but it doesn't fit the acronym nicely. Then we have center and spread. So shape is it symmetric? Is it skewed left or right? Is it bimodal, which means it has two peaks? So it might be up here and up here. If it's uniform, so it could be that direction. It could all be the same value. We don't usually use mound. That's not one that's used a lot. Outliers, and we're going to say for now, something's a potential outlier. We are very quickly going to get a test to show whether something is actually an outlier, but for now you want to say a potential outlier. So that's just a value that's away from where the rest of the data seems to live. And then if there's any gaps, so like in this example here, there appears to be a gap in the data between the two mounds. And then spread, that's how spread out is your data. And so when we talk about center and spread, we're usually going to use two things. We're going to use mean for the center or median. Mean is used if your distribution is symmetric. If you have skew or you don't know, median is the better bet. And so this is for center. Then for spread, if you're using mean, you have to use standard deviation, which we're going to go over in the next section. But if you're using median, you're going to use the interquartile range, which again we'll go over, and that tells us better than the range, which is max minus min. The IQR is the third quartile minus the first quartile. So that way, if we have any outliers, they don't make the range look bigger than is really representative of the data. And one thing for the AP is they always want your descriptions in terms of whatever the context of the problem is. So if we were talking about scores that you got from goals, then you want to talk about, so the mean number of goals scored is 7. You want to make sure you have context. So here, when we're talking about goals scored, the distribution is skewed right. Here we got those points 5 and 9. They're possible outliers. There is a gap between 5 and 9, and there's really only one peak around the 1 and the 2. Outliers, as I just said, potentially 9 and 10. And the center, this is, I don't know if this has actually figured out the median. Oh, it did. The median is 2, so we're going to use that as the center since we have a skewed distribution. All right, and then the spread, if you're doing range, it's from 1 to 10. We're going to quickly go into just giving the IQR. And notice we have context all talking about goals. Now, if you're comparing distributions, you want to compare all those points: shape, center, spread, outliers, and gaps. So you'd want to, in these household sizes between the UK and South Africa, you'd want to compare the fact that their centers both appear to be around 4, because they both appear to be like right here. But the UK, the household size is much more clustered, and it's roughly symmetric. For data, this is pretty good for symmetric data. You're not going to have perfect symmetry. Whereas the South Africa is spread out more, and it has definitely a potential outlier here and a gap from 15 to 25. So there's definitely a more variation in the South African household size. So for what the book says, essentially what I said, roughly symmetric, single peak around 4, and whereas the South Africa does have that, but there's a gap between 15 and 26. And the 15 and 26 are potential outliers. They use the word seems to be. And the median, if you were to calculate it, is higher for South Africa than for the UK. And spread, they give the range here, but again, we're going to lean over and go to IQR. All right, so dot plots, great way to just look at the data. Stem plots, so you might have heard of them as stem and leaf plots. Those are also a good way to display data. I think dot plots are just visually nicer, but stem plots are equally valid, especially if you want to be able to get the numbers off without having to try to count. All right, so for a stem plot, you need the stem, which can be the hundreds place, the tens place, the ones place. It just what makes sense for your data. So here, since everything's is in tens, what do the tens place is your stem, and then the leaf is the ones place. So you just take all the numbers and divide them between the tens and the ones. You can list them out first, but then you need to put them in order from smallest to biggest. So all we did here was rearrange the numbers. And finally, you need a key. The easiest thing to forget, but we need to know how to put the numbers back together. So here you need to say 4, and then the line 9 means 49, because otherwise we could say, does it mean 4.9? Does it mean 490? We don't know. Without the key, we won't know how to put the numbers back together. So really what a stem plot gives you, it's like a histogram on its side. And you can see the same distribution. You just have to be careful when you're doing skewed left and skewed right that the numbers, you're thinking of the numbers correctly. So sometimes it's helpful actually to just turn your head so you can make sure the numbers, if you're going small to big, you got the skew direction correct. You can also have back-to-back stem plots, and that takes like if we want to compare male and females, we have the same stem, and one category goes on one side of the stem, the other category goes on the other. So the males are on the right, the females are on the left, and when you're doing the left, notice small to big goes away from the stem. You will also know that notice this stem is split, which means it goes from 0 to these numbers in this leaf go from 0 to 4 and then 5 to 9. That's done if there's a lot of bunching up, because then by splitting the stem you can see more of a picture of how the data is spread out. Otherwise, like on this one, everything would be clumped basically on the 0 and a little bit on the 1. So this spreads it out a little more to give a more full picture. All right. Now, so stem plot, dot plot, I'll give you pictures of what the distribution looks like, and we also have histogram, which is if we took a dot plot and then sometimes you combine some of the numbers in a dot plot to get the bins, as they're called, for how wide the histogram is. Now the histogram, they do touch, unlike bar graphs where they don't touch, histograms do, because it's a continuous axis. And the bins, it depends on, you don't want them too wide that you don't get enough variation to see what the distribution looks like, but you also don't want them too narrow that you just have one value in every bin. So there's an art to it. One thing to be careful of is if you're graphing things for histograms on your calculator, if you do the stat zoom, sometimes the bin width that it makes, so the width of your histograms bars, can be a little weird. So you usually want to set that in your calculator, and we can go through that in class. All right, so how to make a histogram. Your widths for your intervals have to be the same. You usually pick nice numbers like 0 to 5, maybe 2 wide, 10 wide. It depends how spread out your data is. Figure out how many in each category you have, and then make sure you label your axes, and the intervals have to be consistent again, and then you just graph however high each bin is. All right, so here's the big caution: histograms and bar graphs. Bar graphs are more categorical and use proportions instead of counts, and their bars don't don't touch. All right, so that's all for section 1.2. The next section we'll get into doing some calculations for center and spread. So we'll get a little more mathy in the next section.